these are the constant values. And what is the job of all assembler directives? This all assembler directives job is to assign the location addresses. Okay, because we want our program in the main memory. So at one attempt only, we assign the addresses to all literals. In this example, specifically, we have just talked about the literal table. But again, we are having one more table, that is our symbol table. There also, we need to use this. Yes, if LTORG is not there, then end statement. We need to think about the end assembler directive. Okay. Very good question, Rushikesh. If LTORG is not present here, so what we will do? See, if LTORG, I'll just highlight it. This statement is not available in our example. Okay, and we are having end statement. So after 407, next location counter is 408. Assuming instruction length is 1 only, then 409. Okay, and what is the next statement? What is the next location counter? Next location counter is 410. Right? So if LTORG is not available, in that case, we will shift this address to after the end of the statement, means after the end of the program. So these addresses are become 410, this address become 411. Okay, that is the speciality of LTORG and end statement. Okay, in your program, there might be having more than one LTORG statements. So when it encounter in your assembly program, then and then only you need to assign the addresses. Okay. So this is all about assembler directive we have seen. Now, I'll assume you don't have any doubt. So that's why I'm always telling you about this. Try to be attentive and attend all the lectures. Okay, these examples are very much important. And I'm not going to share recordings on Classroom. I'm recording for myself. Okay. Yes. Any doubt? Still, if you have any doubt, you can ask me. Otherwise, I will move on to the next point. We will solve one example for pass 1 assembler. Simple example for pass 1 assembler. Yes? Okay. Now, so after this, let's go to the design of 2-pass assembler. So what is the design of 2-pass assembler? It consists of pass 1 phase and pass 2 phase. Okay, pass 1 and pass 2 phase. So what is pass 1 and pass 2 phase? Actually, this is known as analysis and synthesis phase. When we design assembler, or when assembler is designed by some researcher, then there is always 2 types of phases are available there: analysis phase and synthesis phase. I hope it is clear. Analysis phase and synthesis phase. So what is analysis phase? Analysis phase means what? We are having our source program. We are breaking down into some tokens. Okay, lexical phase was there in compiler phases. Okay, after that we need to analyze the instructions. Say for example, in our high level language, we are adding 2 numbers. So obviously, when this high level language program is converted into assembly language program, it will be using which instruction? It will be using this add instruction, right? It will be using some add instruction, and for operands, we are having registers available, and we are moving it into move M and move R. Okay, move our opcodes, right? So here the analysis is done. So while analyzing it, you can see these 2 tables. You can see these 2 tables. So these two tables are always, means any assembly program are always in the form of 3 columns. It might consist of label, that is the optional thing, then opcode, okay, then operand 1 and operand 2. Any assembly program consists of label, opcode, operand 1 and operand 2. This is the thing. Okay. Now, what we are doing here, we are analyzing it. So add instruction is there, opcode value for add instruction is 0, 1. And what is the instruction length? It is 1. So if instruction length is 1, increment the location counter by 1. If instruction length is 2, increment location counter by 2. So I'm not confusing you. Here we are talking about all the things from that Dham Dairy book. Okay, that is microprocessor 8085, 8086 instructions. But when you will solve the same example, pass 1, pass 2, for IBM 360, 370 architecture, then you will get some different idea there. Means whatever we have discussed, RX register might be there, SI might be there, right? So just focus on this. Here we are talking about the examples from Dham Dairy reference. Okay. So mnemonic are add sub, their opcode values are given, instruction length are given. Now, whether your example consists of any symbol, so yes, in this diagram, we are having 2 symbols, again and n. So what is important here, if your program consists of any symbol or any literal, whether you have given all the addresses, okay, if not, like this example, here we have assigned the addresses, right, based on the assembler directive and based on the location counter, right? So same thing we have to perform in this synthesis phase, pass 1 phase. And once you are having all the data available with you, you can go for the synthesis phase. And this synthesis phase will convert your overall code, intermediate code, into target machine code. And that is the final version of the target machine code. And you can view your output. Are you getting me? This is the design of assembler. So we can directly have single pass assembler, okay, or we can have 2 pass assembler. Single pass assembler means what? We can convert text program or source program directly into target machine code. And 2 pass assembler means what? We will require pass 1 phase, okay, pass 1 phase known as analysis phase, and pass 2 phase, that is synthesis phase. Okay, analysis phase and synthesis phase. Okay, so if time permits,